Part A. We now have that theta is 170 degrees, and we want to figure out how much that is in radians. So first of all, can you remember that 1 degree is pi over 180, and then we could write radians here, or abbreviate, or you don't have to write anything, rads. 1 degree is pi over 180 radians, so give the exact measure of 170 degrees. Well, how would I get from 170 from 1? I'd multiply by 170. So if I multiply this side by 170, that is an exact value. Yes, you could simplify it, right? It would be 17 pi over 18. In grade 12, they feel that by now you are so good at fractions that you could simplify if you wanted to, so they do not require you to on tests. You could leave your answer like this, unsimplified, and still get full marks. If you simplified it to 17 pi over 18, you would also get full marks. If you simplified it to 17 pi over 19, you would lose a mark for making a mistake. So you do not need to simplify a fraction unless it's a multiple choice question and all the answers are simplified. That's where they're seeing if you still can do that skill. Okay? So that is our exact answer. If we take that and type it into our calculator, 170 pi divided by 180, we get that that is approximately 2.97 radians, which seems like a reasonable number since you know that pi radians is 180 degrees, that 3.14-ish radians is 180 degrees. 2.97 is a little bit less than 3.14. 170 is a little bit less than 180 degrees. Yes?
When we're doing this stuff, if we were to write like a regular equal sign, is that technically wrong?
For this year, they won't deduct you if you write a regular equal sign. Next year, they will in the IB course. So we'll practice it already. When we approximate stuff, we're going to practice approximate. Yeah, practice approximating. Whew. Part B. We have negative 12 pi over 11 radians. Sketch the angle in standard position and determine it to the nearest tenth of the degree. Can you visualize negative 12 pi over 11 radians in your head? Not yet, right? You are not very comfortable with that at all because you haven't dealt with it, okay? By the end of this year, you will be thinking in radians just like you've been thinking in radians since you were 3 years old. You're like, it's just something that I know. But right now, you're not there yet. So I'm going to draw it how we're going to eventually think about radians directly. But right now, you might want to convert that to degrees before you draw it. And that's okay, because you're more comfortable with degrees. But for drawing, if I draw my axis, and this is an angle in standard position starts at 0 there, in degrees, all the way around is also 300, wow, that's a bad 0, 360 degrees. Halfway around would be 180 degrees, and this would be 90 degrees and 270 degrees. If we draw the same thing in radians, well, you'd start with 0 radians. All the way around would be 2 pi radians. Halfway around would be pi radians. What would 90 degrees then be? 1/2 pi, or we could write it as pi over 2. And 270 degrees Well, if this is 1 pi over 2, this would be 2 pi over 2s. This would be 3 pi over 2s, just like 270 is 3 90s. That'll be 3 pi over 2s. If we are trying to draw negative 12 pi over 11, first of all, as a mixed fraction, can you see that that is negative 1 and 1/11 pi? That's the same as negative 12 over 11 is negative 1 and 1/11. As an angle in standard position, I'm going to be starting here. I'm going to be going in the negative direction. I need to go negative 1 pi, which will be to 1 pi, or 180 degrees in the negative direction. And then I need to go 1/11 more. Can you imagine this upper space, this upper half, divided into 11 sections? And then going one more? That is the angle of negative 12 pi over 11. If we convert it to degrees, you might be able to see this even better. So, I want to convert negative 12 pi over 11 radians to degrees. Two ways you could do this. You know that 1 radian is equal to 180 over pi degrees. Hey, what's 180 divided by 3? 60. And if you know that pi is a little bit more than 3, then 180 divided by a little bit more than 3 will be a little bit less than 60. It should be 57.3, but can you see how that mental math can also help you remember that this is the formula and not pi over 180? Okay? So I'm just trying to give you as many ways as possible to say, oh, this formula makes sense to me. This formula, 1 radian is 180 over pi, makes sense because that's just a little bit less than 60. And I know that 1 radian is 57.3 degrees. So if I want to find negative 12 pi over 11 radians, what would I have to do to this side? I would have to multiply by negative 12 pi over 11. So I'm going to take 180 over pi and multiply it by negative 12 pi over 11. What's going to happen with your pi's? You're going to simplify. And 180 times 12 is 2,160 over 11 degrees, which is approximately how much of a rounding do they want me to do? To the nearest tenth? Negative 196.4 degrees. Think about the picture we just drew for negative 12 pi over 11. Does that look about like negative 196 degrees? Yes. The powerful thing about radians is the measure of a radian actually comes from the property of a circle. Because 1 radian is when the arc length is 1 radius. And it doesn't matter how big or how small your circle is, that measure is always the same. Degrees are an arbitrary number. Someone decided to split the circle into 360 degrees. Why that was chosen historically? Was it because there's approximately 360 days in a year that it worked out nicely? But 365 doesn't divide nicely into 4 little sections, so let's make it 360. Maybe that was it. There's mathematicians out there that didn't like 360 degrees, so they invented gradients. Do you know how many gradients there are in a circle? 400. So your 90-degree angles, or 100-degree angles, kind of like the metric system. But that isn't used very often. Okay? So because a radian is actually based on the property of a circle, as you go further in mathematics, it becomes more useful. And so all higher level mathematics is done with radians, and lower level mathematics is done with degrees. So for part C, we want to convert 7.5 radians. Well, we know that 1 radian is equal to 180 over pi degrees. So if I wanted to figure out what 7.5 radians is, I would just need to multiply this side by 7.5. So I go to my calculator, 7.5 times 180 divided by pi. 429.7, does it say to the nearest tenth? Yes. But I do want to go back to B just for a second. Oh yeah. Radian questions without a calculator all the time, every day. Okay, so I want you to go back and I'm going to introduce you to a shortcut for B. Okay? If you want to change negative 12 pi over 11 radians to degrees, you can just change the pi to 180. Not because pi equals 180, but because pi radians is equal to 180 degrees. And see what happened when we did it with the actual calculations. Our pi's canceled out and a 180 was introduced. So it's just basically the same as taking out the pi and putting in the 180. And because pi radians is equal to 180 degrees, okay, you're able to do that. Some of the angles that you will have to know what they are in your head. Like what's pi over 6 radians in degrees?
We need to know that?
30, perfect. How did he do that? Well, pi radians is 180. Can you divide 180 by 6 easily? Yes, 30 degrees. All right, questions for practice on this one are 4, 5, and 7.